So, hi, Alex. I forgot to
Hello.
ask you last time. Is it a German name, actually? So, Alex is a typical German name, you know?
Yeah, yeah, no,
No, there are lots of
but
Alex in Spain?
there are, let's say, not a lot, but there are, yeah.
Okay. The next important question is how warm is in Spain right now?
The temperature, let me check, but it's like 14 Celsius degrees,
Oh, 14. Okay. So,
but
we have,
it's
I think,
14.
-3 or something like this.
Okay, yeah.
Okay, cool.
But it's cloudy,
Okay.
usually, yeah.
So, and your title at Red Hat right now is Director of Developer Experience, right?
Yeah.
So, you are directing my experience. That's your job?
Yeah, let's say that it's like, improving, yes, let's say improving the developer experience of developers, right? I mean, it's like going to conferences and showing them how they can do things maybe better or easier.
Okay.
And yeah, it's more like this. And also in let's say that within Red Hat also providing some kind of feedback, right, to
Okay.
some projects, basically Quarkus, for saying, yeah, well, we can do this in this way and this other way. Well, I mean, it's a bit of this kind of job, but
Okay. So this is what your job is similar to what the Sun Microsystems evangelist did back then, like the NetBeans and Java E and stuff like that, right? So similar job.
we can say it's a similar job. And in the case of in our group in Red Hat, basically we are focused on Kubernetes, Istio, Knative, Quarkus, and nowadays also Kafka. So let's say that we are just focused on this
Okay.
as in these topics, and then yeah, I mean that sometimes some of us has or are predilect to other topics. For example, in my case, I really love to go and speak about testing, but for example, Edson is more about even sourcing. So I mean that at the end, we've got like core topics, and then of us has some specific or content that we love to deliver as well,
Okay.
which is more personal.
So what's your main focus these days?
Yeah, these days, my main focus is Istio. I mean, in the Kubernetes side, let's say in this way, it's Istio.
Mm-hmm.
And then in the Java side, it's Quarkus.
Mm-hmm.
And then in the testing side, it's testing in production. So basically, usually you can see me delivering talks about Istio or Quarkus or testing in production.
Okay, so this is what your interests are, and this is what you will speak in the upcoming conferences, right?
Yeah.
By the way, have you attended the Code One conference last year in 2019?
No, I mean I've just been in when it was Java 1 in 2015, and I've never been again into Java 1 or Code 1.
Okay, so because I missed last year, so I wanted to ask you about the experience. But okay, so let's start with Java, or I think this is Quarkus, what your interests are. What was your road to Quarkus? So how you found it out? Have you got an internal memo at Red Hat? So what's the story behind Quarkus and you?
Well, yeah, but basically, my I mean, it was funny because at the very beginning, Quarkus was something secret, let's say, even inside Red Hat, okay. And my initial steps were to, I mean, that I was creating a workshop for Istio, so I was, creating Istio material. And I had a problem with my computer. It was, an old computer, so I couldn't deploy all the Istio stuff plus all the microservices that I was developing at the same time. I mean, it was really, really slow, and I get a lot of timeout errors. And then I started to create the Micronaut version of these services, right? Because basically I chose a Micronaut because I didn't know that there was Quarkus, and at the same time, Micronaut allows me to create a GraalVM version, so a native execution of the Java code. which works pretty fast with low memory requirements. And I start, writing all my services in Micronaut, and then I send a pull request to the workshop, and then I get it an email saying, well, actually, it's okay to use Micronaut, but we are working in Red Hat with a new secret project, which allows us to also take all the enterprise APIs out there, like Kubernetes, FatJARs, and so on, and making them ground VM compatible. And it was like, okay, then this is how I started learning about Quarkus. And then after 2 weeks or so, it was released internally, so you couldn't start trying it internally. That you need to use some kind of username and password to get into the Maven or the Maven repo. And then after one more month, when the first version was available publicly. So yeah, this is how I knew about Quarkus and my story behind Quarkus. So I would say that after 1 month and a half or something like that, or 2 months that I knew about Quarkus, I was able to, as everyone else, start using Quarkus.
When was it roughly? So when was your workshop? You remember? So which month was last year?
So probably in February or March of 2019,
exactly.
Probably like that.
Yeah, exactly. So but the Micronaut. So Micronaut is also nice. So it worked well, right, with Micronaut?
Yeah.
And people ask me about Micronaut, and actually like the approach about Micronaut as well. The problem is what I see, or what I don't like, is they have their own annotations and programming model, which is a little bit problematic for my clients. And the difference to a Quarkus is that Quarkus looks almost like in a whitefly code, but is repackaged or optimized by Quarkus, right? So this is the main difference, I would say.
Yeah, I always say that, there is some kind of performance, also, that in the sense that Quarkus is pretty much faster than Micronaut, but then we are talking about milliseconds.
This really doesn't matter, I would say.
So it doesn't matter exactly. So this is that some people ask me about this, and it's like, okay, yeah, but it's really a small difference, which is stupid to compare in this way. But I always say that one of the great things about Quarkus is that it uses all the enterprise APIs out there, plus the microprofile spec, which means that it's in a spec. So everything that you learn from yourself using Quarkus, then, in a future project or in another company, you'll be able to use all this knowledge for other technologies. Like, for example, if you want to use a microprofile with, for example, Glassfish or Payara or Tommy, or it doesn't matter. It's still valid.
Yeah.
So you can create your Quarkus project, learn new APIs, then start a new project with, Tommy or Payara or Wildfly, and you can still use all this knowledge to develop your services. And this is something that it's not happening with Micronaut. So you learn new things, and then if the next project is not done with Micronaut, then okay.
Yeah.
Absolutely.
And this comparing the performance it really doesn't matter at all. This is exactly the same, in the JavaScript world. They counting they measure performance of, let's say, get element by ID versus document select something, and this is like 1 microsecond slower or faster. And if you hit the server once, it doesn't matter at all, because this really doesn't matter. And you are right with the enterprise and microprofile API. And now a story. So I coach, funny enough, several startups right now, and in one we had a stock ThinWar Java project, and so he asked me, what we can do. So is there something new on the horizon? So okay, if you like, I can show you something, and I introduced him to Quarkus, and the project was like mid-range, I would say. I would say 20 to 50 JPA tables. So this is more than 20. I would say more like 50 JPA tables, JAX-RS endpoints, WebSockets, SSE, and so the typical, I would say, so like Jakarta architecture. And in, I think, half a day, we migrated to Quarkus on Hibernate ORM, and yeah, it worked, and it starts faster and consumes half of memory, which didn't matter for the startup at all. But I mean, it's slower, faster, and yeah, he's excited right now. So yeah, so it really works. So, and now my story about Quarkus, because it's also funny. I got from Red Hat from one developer, like we had a chat, and he said, soon we will release something you will like. It's like, I don't believe in it, because, you know, we got Whitefly Swarm. I didn't like it at all, because the problem Red Hat had was the Whitefly was small enough. So for me, it was not like huge difference using, you know, Whitefly Swarm or Thorntail over Whitefly. I never got it why I should switch from Whitefly full to Thorntail. And the same story in Payara. There's Payara and Payara Micro. So, okay, I never use Payara Micro because the Payara is fast enough. And so I suspected, you know, there would be like Thorntail optimization. And I say, okay, another one. But as Quarkus came out, I just, okay, now I'm curious. And I created a project. I generated, or just Maven Clean install, look at the plugins. So, okay, lots of plugins. I don't like that. But let's see what happens, right? And run the project. And there was the jar. I immediately unzipped the jar and looked inside what's inside. Like, okay, interesting. And then I found in lib lots of jars. And I say, that's actually the very first time which something new happens. And what I really like at the beginning is the separation of business logic in the, you know, business jar, and all the infrastructure, which is immutable. It can be shipped separately to Docker, which was amazing. And I was like, from day one, it was, I think, in March. This is why I ask you. So it was from day one, this was like 0 something. So 0, I confused the Quarkus version with Docker versions. Yeah. So, but yeah, this was the first time it's like, okay, this is the true next step, you know, from Java EE deployment model to something new, which is really worth considering, because it's not like, you know, something new. It's like, looking what developers are doing and, you know, improving the Jakarta EE deployment model or microprofile deployment model, and make it viable for, or improving it towards clouds and containers.
Yeah, in fact, with Quarkus, you still have an option that you need to set it specifically to create a Uber jar. I mean, that, let's say that like a Spring Boot jar, right? That where everything is packed inside a jar file, because there are some people that ask me after the session, hey, can I do a Uber jar? I mean, in you know, everything packed inside the jar. And I said, yes, there is an option that you can use it. But I always explain exactly what you said, that the good thing about having the infrastructure jars and the business jar in a different place is that now you can cache the layers or the Docker layers. So I mean, at the beginning, it's true that you are updating all the versions frequently, or adding new extensions or new jars and so on. But when the project is stable, usually what you're doing is just bug fixing. So you're just changing your business logic. And then it's like, why you want to, you know, spend more and more time on sites creating new Docker layers when the lib layer is always the same. So this is one thing that is really cool about Quarkus, that you can, you know, reuse the Docker layers all the time.
Yeah, I never got actually, really, I asked all the time, what's the point of UberJars and FatJARs? And I started asking, I think, 5 years ago, and no one could explain me that. Because if you think about this is completely wrong approach, you know, because most of the business logic you write is tiny, and you will have to repackage everything and reload over and over again, or so, you know, only a tiny fraction of the entire ship deployment unit changes. And Quarkus keeps it separate. But recently, I found a use case for a UberJar or FatJAR, and this is, I use Quarkus right now for developing a desktop app, so it's a little bit funky. So it's more like, you know, I don't know whether you're aware of how it's called, the Electron app, something like this, you know, where, like desktop app where server is behind. And I use Graal VM for that, but I think the newest Quarkus was the GraalVM was backported to 13 something, and there was a bug in GraalVM with JGit, so it didn't work as I expected. So I had to use for a brief amount of time the Java version, and then I had to know to copy all the jars. And this would make sense for desktop apps. They can ship actually a jar in case you cannot use GraalVM. So this is what this is typical bare metal deployment. If there is no Docker, no Kubernetes, and you have to ship your code on bare metal, this is where UberJARs or FatJARs make sense. And by the way, what is the flag? You know it for the UberJARs?
I can check it in a moment.
Yeah, give it the show notes. This would be nice. Send me a mail. I will put it to show notes because for this particular case, for desktop apps, UberJARs are great. For all on my project, they don't make any sense. Okay, perfect.
Yeah, it's really I mean that it's just a plug that you put it in your in the build plugin and it just works. Yeah.
So what you are working or what you will talk in the upcoming conferences about Quarkus? So do you have like a roadmap or just talk about what do you talk right now? Deployment. What is the the killer features of Quarkus? So what's
well, just one thing. I found the plug. You just in the configuration section of the plugin. You just there is a flag that is called UberJAR. Right?
Okay.
Like this. You do UberJAR true.
Okay.
And then you build a UberJAR instead of the regular one. Yeah, just.
Okay, so I will try it because then I will wait until Quarkus is released with the new Graal, and then it should work in my case. Perfect.
Yeah, and if you're using Gradle, you just need to do Gradle Quarkus build minus Uber minus jar, and then it creates the UberJAR if you are using Gradle. So I mean it works as well.
Are you a Quarkus committer? So how deep are you involved with Quarkus, or just more a Quarkus user? So what's your role?
I've committed some code, but I mean that usually it's like minimal bug fixing or improving the documentation.
Okay.
Usually it's this kind of a stuff that I'm committing. Then also since I'm writing a book about Quarkus, which is called Quarkus Cookbook, which is a cookbook with a lot of recipes about Quarkus. Then I just prepare a lot of examples for this cookbook, and then I usually found things that maybe they are not working correctly, or that I think that it could be done another way, or simplified somehow. Then you can usually see me really active in the Google groups of Quarkus. They're asking for help or asking for clarifications or suggesting improvements, let's say. So I would say that I'm not in the Quarkus team, or I'm not really active. But I as I said before, I just send some pull requests about documentation and minimal code and things like that, and I'm in the top 50 committers. What I mean with this is that usually people are really scared, right, to contribute to an open source project and say, why I should contribute, why I should do this or that. And it's like, look, you can improve documentation, which is something that, it's easy to do. It's not complicated. And you can, reach really quickly the top 15, right, of the committer, which, it gives you some visibility with the community, not just Quarkus community, but Java community. So this is my interaction with Quarkus.
Okay. Why we're talking is because I had so for the desktop app, for instance, I wanted to prevent caching. So I wanted that the cache is completely disabled. So and I blogged about this, how to do it with Quarkus with Netty and the microprofile configuration. And you responded on Twitter, just use the no cache annotations. Like, that's interesting that, the Lord of the Jars is now one of the Quarked developers. And I pinged you, and this is why we're talking right now. So this was the story behind.
Yeah, about caching, you can do this no cache for modifying the HTTP headers. But now for the version 1.2.0 that it's almost released, I mean that it's now it's 1.2.0 CR1. Okay, so it's a candidate release. But now there is a new extension which is called cache, which allows you to annotate your methods to cache the method calls as well. So we are working.
But I'm talking about HTTP header caching, right?
HTTP. Yeah, I know. Yeah. And this is already supported. But if you are also interested in caching at the server side,
okay,
also for the 1.2, it's going to be supported.
And where it's caching, in InfiniSpan or where?
No, Caffeine.
Caffeine.
Yeah.
Okay.
It's a Java cache, at least for this first version.
Okay, and why not InfiniSpan? Because there are trouble with Graal, or?
Well, in fact, there is an extension about InfiniSpan, so you can use InfiniSpan, but not as a, let's say, as a distributed in memory cache. It can be used InfiniSpan, but in this specific case, it's it's not a distributed cache, Caffeine. Okay. It's just caching the memory calls.
And I have also some questions from clients, and also wondered myself. Are you aware of Helidon?
Yeah. From Oracle, yeah.
Yeah, and what Helidon does is you can write your own main method and then invoke, Helidon. And I look, but it was half a year ago on Quarkus code, and you could do this as well. But is there like official way of doing this where I would like to write my own main method? Let's say, fetch some configuration and then invoke Quarkus because why for batch processing, for instance, So I can write my own batch. It just wakes up, does something, and then I will kill it, for instance.
There is a discussion about this, and there is a Google group topic that we are discussing about this, and it's something that it's there. Let's say it's under discussion. I think that even there has been some work on this direction, and I mean that I don't have the roadmap of knowing exactly what when it's going to be released, but I know that it's been discussed and everyone agrees that it's interesting to have it, and I know that they are working about it. But I don't have, let's say, the exact details of when this. But I know that this is going to be possible in the near future.
Because one is batch processing, so I got the question several times from my clients, but also for me. So over the years, I've wrote a lot of Java command line tools for myself, and so writing such a tool without from scratch is a little bit painful if you know CDI. So of course I could use CDI, but I didn't like that to have dependencies, whatever. But with Quarkus, it changes the game because I say, okay, it's exactly the same program model on the server, so I could misuse Quarkus for write my CDI or my command line interface application, and use, for instance, CDI because it's faster, as I mean, to wire classes, and I could pass, the arguments from the main method, so the command line arguments, and make them injectable very easily. Mm-hmm. And this would be my personal use case, and I think there are lots of such projects. And and you could even combine that with Pico CLI and something like this. So it would be interesting, interesting use case.
Yeah. In fact, we are not far away from this, but because, for example, if you are using K-streams, so the Kafka streams approach, you don't need to add the REST easy dependency.
Exactly.
If you don't want, and this is something that is now supported. I know that it's possible to do it.
Oh, but so I could actually experiment. So what we could do, this would be an interesting experiment. We could write an extension without any dependencies, just hello world, and then Quarkus, should write the hello world and die. So this would be the use case. So this is actually then done, right? The first iteration. And the only thing which would be interesting is to pass command line arguments somehow to the plugin. And I look at the code, it would be trivial to implement actually. So there's almost, but this was half a year ago. You could absolutely pass, the arguments to the application. So okay, cool. So what else? So what else are you going to talk? So what excites you the most with Quarkus?
Well, one of the that things or a lot of questions that I get about Quarkus is like, okay, this means that Quarkus is going to be a substitute of a Spring Boot, right? This is a lot of questions that we get it, and I always say the same. It's like No, Quarkus is it's another tool that you've got there, and sometimes it will be better to use a Spring Boot, others Quarkus, and also it depends on the use case. I mean that, for example, one of the things that takes the attention of everyone is like the boot up time, right? That they say, yeah, look, this boots in 5 milliseconds or 10 milliseconds, and a Spring Boot takes 3 or 4 seconds to boot up, right? Or 8 seconds to boot up, depending on the application. But I always say the same. It's like, it depends on your use cases. For example, if you have a stable service, which you don't need to scale up or scale down, which is, a service, then you can use a Spring Boot and probably booting up in 8 seconds, it's not a problem. But if you expect that your service might need to be a scale up quickly, scale down quickly, because, you get it some high level traffic at some point and then you get it down and so on, and all these, different level of traffic, then probably it's really interesting to use Quarkus and GraalVM.
But
because now,
wait a second, you're talking the Spring Boot boots in 8 seconds. This is way too long. I don't have a lot of experience with Spring Boot. I actually no experience with Spring Boot. All my projects are somehow Jakarta-y microprofile or Java-y microprofile Jakarta-y related. But most of my Whitefly, Payara, OpenLiberty, and Tommy applications, they boot in 3-4 seconds. I mean, this is the 8 seconds. What is it? Is it like?
I mean that. I'm just. I don't have a specific example. I mean,
no. This is really okay.
Yeah. Because usually when I have some kind of a Spring Boot examples, which are really simple examples, okay, it boots up in 3 seconds, right? Then I'm just saying, okay, if you need to do some kind of, for example, flyway migration of the database schema, plus update any distributed cache, plus boot up the Spring Boot, plus whatever, right? Plus the lazy initialization of all the classes. Then if you sum up all this time, maybe you can easily go to 6, 7, 8 seconds, right?
Yeah, sure.
Because one of the things that everyone needs to be aware is that the important thing is not the boot up time. I mean, this is important, right? But the important thing is the time it takes to serve the first request. And this is something that you need to really take care, because in case of a Spring Boot, you'll see that in the latest versions, they're improving a lot the boot up time. But of course, they are improving the boot up time, and you are paying something. And this something is that a lot of stuff is, it's allocated at runtime. So there is a lot of lazy initialization. And this means that you boot up really fast, but when you send the first request, and this is where everything is then routed, then it takes a lot of time to serve this first request, right?
Yeah. What I remember, I had already chat with the Alexis from prior from the Glassfish team. And what I remember was there was a Glassfish V2 and they introduced Glassfish V3. And everyone was excited, about the modularization and everything was loaded on demand. But I took a look at that and I'd say, okay, but this is, for me, it's just completely stupid because I need most of the things. So I always will have to wait, There is no use case just to boot, servlets fast and then wait until JAX-RS boots. And back then, I used also the admin console a lot because of monitoring. So if I booted, the Glassfish booted immediately, and then I just opened the browser and said localhost 4848, and I had to wait, 5 seconds until the admin console boots. It's like, this is all crap. And the Glassfish V2 was in total faster boot time because all the plugins were eagerly loaded. So so for me, it was better experience because whatever I need was already there. And in Glassfish V3, whatever I hit, I had to wait first, So this is an interesting trade-off between lazy loading and eager loading and developer experience, right?
So,
but back to Quarkus. So there is one killer feature in Quarkus, what I at the beginning completely forgot, actually. And this is what Quarkus also does is it optimizes Hibernate. And this is kick-ass because what usually takes time at boot time are not loading of the CDI, rather than parsing and the named queries do all the stuff from Hibernate. And what Quarkus does, it reads the persistence XML and understands the deployment and generates all the metadata at build time. So at runtime and is faster, and the startup time is faster. And this is what I meant. This is the true revolution. It's not like a micro optimization. This changes the game.
Yeah, but it's not only this configuration. This process during configuration time is, for example, if you are using the MySQL driver, then in Quarkus knows that there are some classes that are not required by MySQL driver, for example, because they are specific for Oracle driver or PostgreSQL driver or whatever. So they remove these classes as well from your application, making your application faster to boot, faster to smaller in terms of size, because we are removing all these classes that are not required.
Yeah, so, and this is very similar to tree shaking in JavaScript. This is the name is tree shaking. This is, I think, is lesser known in Java world, but in JavaScript developers say no. Tree shaking is like they don't ship the entire framework. They have a build process, where they pick only stuff which is really needed in production, and everything else is never ships.
Yeah.
Yeah. And what I wanted to mention also on that note is, and this is what I really like, because all these years, if you look what I did is, I always pulled the maximum server. I was not interested in micro optimization. I was only interested in developer experience. So for me, it was starting fast and be productive, the paramount. And what I really loved with about Java EE is I got one single dependencies. Okay, now I have two, Java EE or Jakarta in microprofile, but still just two and always the same. And then I could rely to everything there, and all the dependencies were on the application server. And now it's very similar in Quarkus. I have all the dependencies, but at the build process, Quarkus will remove whatever is not needed and just ship what is really needed. And this is actually great. Computers should do the work, not we developers. I actually don't care about curating set of dependencies. I do Java for more than 20 years. Yeah, more than 20 years. So this is a boring task to care about which library to choose and when.
This build process, it's changing everything, but at the same time, it's if you think about it, it's helped us to be able to create a native executable, because at the end, when you're trying to compile a Java program to Graal or using GraalVM to a native executable, then the more things that you have, the more time it takes and the more difficult it takes to adapt all these transformations of the JVM code into a native executable. So the less things that you have, the easier for a GraalVM process to generate an executable or a native executable. So yeah, it was perfect in both directions.
Yeah, it is actually perfect storm. You have to know what to pass to GraalVM for optimization, and because you have to know what to do, so you had to tree shake the application and just pass along what is really needed. If you do this, is the deployable for hotspot smaller and faster as well. This is the interesting part.
At the same, and let's say, and a side effect is that then you need less memory. And I always say this in my presentations, that I know that the memory is cheap. It's something that is cheap. I agree. But now, this didn't happen in the past. But now, when we are in the cloud era, that you are paying for CPU, paying for memory. So, for example, if you go to Amazon or Google or any other, or Azure, then you are paying for CPU and memory. And this means that the CPU that you need, the memory that you need, means money. So if you can cut down the memory usage, it means that probably you can start using, let's say, less powerful machines. And if you start using less powerful machines, means that the cents per minute that you are paying is less. And this is like a side effect. So it's like you can use Quarkus And you said, yeah, but what's the difference in the memory? It's like, okay, it means that you have half of the memory in comparison with other solution, so you can start using cheaper machines, right?
Yeah.
So you are saving money from the total amount of cents per minute that you are paying in a whole year.
Mm-hmm. Do you remember the data access object pattern, DAO?
Yeah.
Yeah. I think it was, I will have to look it up. I've wrote a blog post like 10 years ago about this data access object pattern. And what I implemented once is actually for interesting purpose, like a generic data access object pattern. Mm-hmm. What it did, it just wrapped the entity manager without any additional functionality. It was like, parameters with Java templates, generics, and return values. So it was actually pointless. But the interesting part is 10 years ago, I had always, in every project we started, to justify, why I'm against DAOs. DAOs are great because if JPA changes in the future, they have the DAO and then they can swap, JPA with something else. And there was actually no way I could convince, in the project, all the developers and architects. So what I did back then is I introduced my own DAO, which didn't make any sense. And then all the discussion stopped. And after a few iterations, I removed the DAO and no one complained because we had other problems in discussing the DAO. And it was the same with the memory, I did on my microservice workshops, I did, slides from my server and compared it with 18K about the costs, how RAM is, even cloud. I mean, in most projects, if you count the amount of machines you need, it really doesn't matter whether you will use small server or huge server. But what I do right now is I do the following. At the beginning of the project, workshop, whatever I'm doing. So I show, Whitefly application, let's say, because this is the best comparable with Quarkus. And then I use the same code and then move it to Quarkus. Hotspot VM, then everyone is already excited, and then show the same result with Graal, where Hello World consumes 5 megs of RAM. And then all the discussion stops. And I say, look, we can be smaller than Node.js with Quarkus if you like. And now, there is no more discussion. So for me, this is a huge bless, whether we are shipping with Quarkus in Hotspot or with Graal, the whole discussion stops. Because it's really hard to be smaller than Quarkus these days. And even if you compare this with Node.js, which is, I would say, the true competitor of Quarkus, then it is smaller or a similar size. So what I saw is smaller than Node, which is great. So I would say now, nowadays, 10 years later, I don't have to justify the DAO. I just use whatever is appropriate for my clients. And with the Quarkus trick, I never, 2 years before Quarkus, I also explained memory and how expensive it is and what's the difference with the cloud. And now I don't even have to explain. I just show it consumes Hello World 5 meg with in native, 20 in or 200 with Java, and stock Whitefly needs 400 megs. Because it comes with the minus XMS and minus XMX settings, right?
Yeah, this is something that, as you said, or let's say, or examples or comparisons between Quarkus and Node.js is like Quarkus uses less memory than Node.js. Of course, using exactly the same example, right? I mean, preparing the same example, comparing both, Quarkus requires less memory. Of course, probably if we compare more and more use cases, maybe we could find use cases where Node.js performs better, others than Quarkus performs better. That's true, that can happen. But the truth is that if it's not exactly the same, it's better Quarkus. And the good thing is that it's Java, right? So you don't need to learn anything new. It's just
exactly.
Java code with your enterprise APIs, and we are performing somehow better than Node.js. In fact, we also have an example, that it's with Knative, and we are just sending traffic to Node.js Node.js service and a Spring Boot service and a Quarkus service with GraalVM, right? And we are scaling or we are measuring how these services scale up with Knative automatically. And we've been able to show that Quarkus scales up faster and better than Node.js. So it's not only about the memory, it's also how both services scales up. Of course, I mean that in this sense, a Spring Boot scales up really bad. But it's normal because I mean that we are comparing. I mean that I think that the comparison it's not fair because in both cases we are comparing JVM runner, which is a Spring Boot, with some native runners. So I know that it's not fair.
But you could compare. This would be interesting. Spring Boot JVM and Quarkus JVM mode. You know, this would be interesting comparison.
Yeah, it could be interesting, but then you need to compare because in this case we are using Knative to scale up automatically, and we are sending thousands of requests per second, right? So then I mean that any solution that involves the JVM probably it will struggle a bit. Right in scaling up.
Sure, but you could
basically in this demo,
just Quarkus versus Spring Boot without Node.js and JVM versus VM. This would be interesting comparison, even for you internally. You know, to see how it performs on just Hotspot.
We have this this comparison, but it's not using Knative. I mean, it's just JPA examples with Spring Data JPA. Okay, and then another with Quarkus, and then we start both of them in JVM mode with the hotspot. So it's it's fair, and we know that we are using less memory and faster first requests than a Spring Boot.
And how much faster is it? Roughly, just don't tell the numbers or roughly. So what's
I don't remember exactly because this has been changed and we improved it. But I think that it's more or less, it's like in case of Quarkus, it's like 2 seconds, okay? And in case of a Spring Boot, it's like 3 something.
Okay.
But it's more or less like this, yeah.
What would be also interesting, that would be really interesting, just take, Whitefly, because they're the same libraries, Whitefly with Hibernate or M, and deploy exactly the same application on Quarkus and compare Whitefly versus Quarkus. This could be interesting.
Because, I mean, it's
because they are the same libraries, and you would just see, the optimization which happens on build time, what it actually brings to the table, right?
Yeah. In fact, we are faster and less memory in Quarkus in JVM mode and in Spring Boot because of the compilation process.
I just did several. I never compare it to Spring Boot, but I compare it with all the application servers, and usually it is at least half the size. So as the Quarkus is half the size of common application servers, which is already remarkable. I mean, this is the first time there's a real difference in memory consumption.
I always say that one of the great things about Quarkus is not just this. I mean, it's really nice, this the memory consumption and also the performance. It's really nice. But one of the things or the examples that I always show in my demos of Quarkus is the developer mode, right? That you can just change something, save the file, and this change is reflected automatically to a running instance.
Yeah.
And I mean the great thing about this is that I'm not showing a hello world, right? I'm not saying, look, hello world, I changed hello world from goodbye world, and the change is reflected automatically without having to repackage your application and stop the previous application or start the new application and see what's happening. No, I'm not showing this. What I'm showing is that I have my application with JPA, in fact with Panache, right? And then I add a new column. And the good thing is that I add the new column, I save the code, and it's and then I just do the request, a new request, and my application is updated automatically, but my database is automatically updated as well, adding this new column.
Yeah.
And it's really nice. I mean, it's people just see this and say, "Wow, that's awesome!" Right?
Yeah.
Because it's like I can start playing with JPA, trying queries. What's happening if I do this query? What's happening if I change this query to this other thing? What's happening if I add, this new column or whatever? And without having to restart anything, you just see the results. And this is something that...
I can, absolutely. But what happens behind, so how to start a thing is Maven compile Quarkus :dev, and it starts. But I wondered myself, how good is it? And what interests me, what happens actually behind the scenes. And the cool story is, what happens is, this is what happened in the past, hopefully this is still the case, Quarkus starts entirely new application behind the scenes with a new class loader and drops the old one. So because it's so fast, there are no further tricks required. And the result is, it works really well if you change whatever you like. In some corner cases, I found only problems if added new extensions at runtime. So sometimes it doesn't work. But for changing properties, application.properties, and so forth, this is works really great. And what helps me to understand what happens behind the scenes, says okay, it actually starts an entire new application behind the scenes and drops the old one, right?
Yeah, and it does with like half of a second or something like that.
Yeah, exactly.
Regarding the extensions, I know that this was a problem in the past, but I think that it was in the 1.0.0. I think that, before the the latest 0. something that we delivered. We fixed this problem, so you could add any extension in your pom.xml, and it's the running instant also. It's notified with the change, so you can even add new dependencies. And so I mean that maybe there is one specific problem in one specific extension, but I would say that we have been working also for detecting the changes in the pom.xml or the build.gradle as well, and populating these changes as well to the running instance.
Yeah, and even if it wouldn't work, so in this particular case, what I did is Control-C, so I kill Quarkus and just say arrow up, enter, and it just restarts in 2 to 3 seconds, depends how big the project is, and you are set. So there's actually
this is what I was doing when I was showing Quarkus before we added this feature of detecting changes in pom.xml. I just did this thing that just, okay, now if you added a new jar, it's something that you are not usually doing it in your project, so you kill it and you start it. But now it just works, and it works with Hibernate, it works with Kafka, with K-streams. So you can start playing with K-streams DSL and just inspecting the result all the time. So you can say, okay, I'm going to do a join here, whatever, and you see the results. So it's really
with Kafka
nice.
streams. And also what's nice extensions regarding this, but I will save it for another episode, otherwise we will talk the entire night, but is I think it's called microprofile or small array streaming operators. And what you can do is you can have incoming and outgoing annotations. And with the incoming, you can map to Kafka, and outgoing, let's say, to WebSockets. So you can have another Quarkus, let's call it micro or a nano service or whatever, who listens to a Kafka topic and translates the calls and exposes everything as a SSE or WebSocket, for instance, right?
Yeah, and it's not just because this annotation comes from the microprofile reactive streams spec.
Reactive stream, exactly, right. Mm-hmm.
Yeah, and it's not just Kafka. I mean, you can say incoming from Kafka or going to JMS.
WebSockets, that's what I said, or Artemis or whatever.
Artemis or whatever. I mean, it's not just, it's any messaging system, and just annotating and configuring all this stuff in your application.properties file.
Yeah.
It's really,
I think what I don't like about Quarkus, a small thing, and I actually wanted to open an issue, is that the configuration name is application.properties, and I think it would be better if this is MP config properties, like in microprofile,
Yeah, it's funny that you said this because, I think that it was yesterday, Max Anderson, sent a message to a Google group saying why the file is called application.properties and not Quarkus application.properties, something like that, right?
But because I always have to remember now, if I port something from application servers to Quarkus, the name is mpconfig.properties and in Quarkus application properties. Now I know it, but at the beginning I always copy the file and nothing happens. Like what the hell? It's like, okay, I have to rename that. So exactly, and I could assume I probably know the reason because Quarkus doesn't have to be microprofile. You could run Quarkus without any microprofile relation. But what you could do, you could support both. You could search for application.properties first. If there is nothing, then search again for mpconfig, and this would be a nice solution, I would say.
Yeah, this is what Max said in the thread.
Okay.
That probably it will be interesting to not remove one, but support more than one.
Yeah, exactly. So what else? So now my complaint is over. So this was the only thing which I didn't like about Quarkus. So when your book is done, you know that?
Yeah, in March it's done.
Okay.
And so it's like in 2 months. In fact, it's almost everything written. And we are and now I'm finishing the security part, and then it's done. And in March it's going to be done. It's going to start the official review process, and then probably in July we'll be ready ready. Ready and printed and so on. So in July, August, in summer. Let's say in summer, it's when everything is going to be ready.
What are the coolest recipes from your book, or your favorites? Not the coolest. What are your favorites?
Yeah. Well, for example, one of my favorites is about how writing Kubernetes operator, for example.
Perfect.
This is one that I really like because it's really easy now with easy and faster to create operators in Java with Quarkus. In fact, we are relying on the Fabricate Kubernetes client, but this is something that it's a project. But this is one recipe that I really love because you can see how powerful are Kubernetes operators and how easy it is to write them in Java, and then you can compile them into native executable, put it inside the Docker image, and it works really fast. This is
what you did then? What you've wrapped as operators, or what you're starting in your recipe, in your book?
Yeah, in this specific case, the operator that we are creating is there is a Docker image which is called Wells High, okay, Wells Say, sorry, which just puts a message right in the console.
Okay.
Let's say you set as a property what the message you want to put, and then they send this, and then basically you need to create your YAML file, your deployment file with defining the pod, the deployment, the service, the container name, the image, all the properties that you need to set in a pod. And then what I'm saying is like, okay, notice that if you want to change the message, you need to create another file with all these properties. So you need to start doing copy paste from this deployment to another deployment and so on. So what we are saying, like, okay, how about just creating one YAML file with just one property, right? Let's say the message that you want to print. And then then there will be a process, which is the operator, which will take this message and fill this message with a predefined deployment definition and just deploy this new say service, but with the new message. So from the point of view of developer, you develop the Java operator, and then as the point of view of a user, you just create a YAML file with the message, and then you send this YAML file, and automatically Kubernetes will pick it up, this file, and print the new message. So it's like a hello world operator. I don't want to.
But this is useful. So hello world is always useful because you can replace the hello world with something else, and it's a good starting point to do something useful.
Yeah. Most of the book, I would say that it tries to create hello world things, right?
They are the best. This is also my way of explaining things. Just print something really simplistic because you would like to understand what the technology is doing without too much business logic.
And then another recipe that I really like is the circuit breaker, because we show how the circuit breaker works and how you can make or how you can inject failures and see how the circuit breaker behaves and this kind of stuff, right?
But the microprofile circuit breaker, right?
Yeah.
Okay.
Yeah, microprofile fault tolerance. with
perfect.
circuit breaker, block ahead, timeouts, and so on, retries. Yeah, this is another that I realized. And now one of the one that I'm working right now is the Vault integration. Vault, this HashiCorp Vault
this is useful.
Project.
This is really useful.
Yeah. These parts of the recipes are really loved. That because now I'm from version 1.0 and now in 1.2 as well, we have improved the support, and I'm enjoying so much writing these recipes, because it's something that, as you said, it's really useful. It's about the security, how to manage your secrets, how to manage your secrets in Kubernetes, and it's something that I'm really enjoying. And
you know the Airhacks TV, so my monthly streaming show on YouTube. So, and there were, I think, 3 questions in a row about how to manage credentials on Kubernetes. And my first answer was, just use microprofile config. And I say, but then you will see the username and password and credentials in the Docker environment, and this is not viable. And then it was back and forth. And in the end, I said, okay, now take a look and Quarkus Vault, and this was solve the problem, because then the Vault, injects the credentials in a kind of RAM disk, and they can be picked up by microprofile, and you are golden, right?
Yeah. One way of doing it this way, right? So it's that the extension connects to Vault and grabs all the information. But now also there is other options that they do as using the Vault Kubernetes agent, which basically is a sidecar container that connects to the Vault, and then inject this information in the /var/secrets/something. So you can use the extension, or you can even use this sidecar container, which is provided by the Vault project, which allows you to inject these secrets directly inside the container. But this is the.
So perfect. So what will be the name of the book?
The name is Quarkus Cookbook.
Okay, and the publisher is?
O'Reilly.
O'Reilly. Oh,
O'Reilly. Cool. O'Reilly. Yeah.
Perfect. And where people can find you on the internet?
They can find me in Twitter, which is Alex Soto B. They can find me in LinkedIn, Alex Soto, and in GitHub, it's my username is Lord of the Jars, and I also have a blog which is called lordofthejars.com.
Exactly. So thank you, Alex, and hear you next time. Hopefully, I would like to find some time. I would like to invite you again and chat about Kafka.
Sure, it will be a pleasure.
Perfect.